guess and check again. We take two parentheses. If we want to, we can keep 2y and y the same. The 7 and the 3 we can also keep the same. But to guess this time, we can switch the positive and negative signs. So we can make it a -7 and a +3. Checking this time, 2y times a +3 would be +6y. -7 times y would be -7y. And this time, combining like terms, we'll have -1y. -1y again does not match up with -11y, which means this is an incorrect solution, and we'll have to guess and check again. Another parentheses that we could try. 2y and y will stay the same, but this time we can switch the 3 and 7 around. We can have 3 first and 7 second. And again, one has to be positive and one has to be negative. We can check the +3 and -7 first. If that doesn't work, then we can switch the signs around. Multiplying the outside, 2y times a -7y, it's -14y. And 3 times a +y would be +3y. -14y plus 3y. Subtracting those would be -11y. -11y does match up with our middle term. As long as it matches up, that means it checks out. So our correct answer is the one that we guessed, 2y plus 3 and y minus 7. Second question, and last question for the section. 14 n to the third plus 23n minus 15. And again, if you wanted to, you could factor this using the diamond and factor by grouping, or we can also factor by guess and check. First guess is the numbers that multiply to get 14. And again, we can either guess 14 times 1 or 7 times 2. If we try 7n times 2n, that's one way to guess, and if these do not work out, we can go back and try the other combinations. Two numbers that multiply get 15 or -15 in this case. We could do 15 times 1 or 5 times 3. Again, just to guess and check, you guess and see if it works out correctly. We can first try 15 and 1. Since it's -15, means one number is negative, one number is positive. And again, just by guessing, see if it works out. We'll try -15 first and +1 second. To check and see if it matches up, this time it has to add up to 23n when we multiply the outside terms and the inside terms. 7n times a +1n would be 7n, and -15 times 2n, -15 times 2 would be -30, and n would stay the same. Combining these, 7n minus 30n would be -23n. -23n is not the same as +23n. So if it's not the same, not exactly the same, this answer does not work out. And again, guess and check. You can either guess completely new numbers, or we can take the one that we had before and change a few numbers around. If we leave 7n and 2n the same, we can also leave 15 and 1 the same. But to guess another answer, we can switch the negatives and positives. So this time we'll make it a +15 and a -1. Multiplying the outside terms, 7n times a -1 would be -7n, and 15 times a +2n would be 30n. And combining -7n plus 30n, it's the same as 30 minus 7, would be 23n. This time 23n does match up with our middle terms. So if it does match up again, that's the correct solution. So our final answer would be 7n plus 15 and 2n minus 1. first section of notes today is titled Factoring. Difference of squares. Factoring difference of squares. The first problem is x squared minus 4. When you factor the difference of squares, you only have two numbers here, or two terms. And in every case of difference of squares, you'll be able to take the square root of each of these terms or each of these numbers. For example, the square root of x squared would be x, and the square root of 4 would be 2. Your first answer, take the square root of each one, and you have x plus 2. The second answer, second parentheses, is exactly the same, except you change it to a minus 2. So x squared minus 4 factors to x plus 2, x minus 2. Second question, y squared minus 100. Again, to factor difference of squares, take the square root of each term, y squared, the square root would just be y, the square root of 100 would be 10. Second answer, exactly the same, except you change it to a minus 10. If you wanted to, you could switch these parentheses, have the y minus 10 first and the y plus 10 second, and that would be the same answer. Last question for this section, a squared minus 169. Again, the first step, take the square root of a squared, which would be a. The square root of 169 is a number times itself, that's 169. And that number would be 13. And your second answer, change it to a minus 13. The reason this works out is if you FOIL it out, the outside term will always be a negative, in this case negative 13 term, negative 13a. The inside term will always be a positive 13a, so the outside and inside cancel, and that's why there's no middle term. But to solve difference of squares, take the square root of each term. The last section of notes today is titled More Factoring. Difference of squares. First problem we'll do is 4x squared minus 81. Just like before, we only have two terms or two numbers. Both of these, again, we can take the square root of. For example, 4x squared, the square root of 4 would be 2, and the square root of x squared would be x. So our first term would be 2x. Square root of 81 would be 9, so our first parentheses would be 2x plus 9. Same steps as before. The second answer is exactly the same, except it's minus 9. So 4x squared minus 81 factors to 2x plus 9 and 2x minus 9. Again, these two parentheses you could switch around, have the minus 9 first and the plus 9 second. Last problem that we'll do together for the section, 16y squared minus 25. Again, take the square root of each number. In this case, it's 4. Take the square root of the variable, which would be y, and take the square root of 25, which would be 5. So your first parentheses would be 4y plus 5. Second parentheses, just change it to a minus 4y minus 5. Title of the first section today is Review, Adding Fractions. In this section, we'll review how to add two fractions together. Two definitions or two steps for these questions. First step is must have common denominators. And the second step, to add fractions, reduce when possible. When adding fractions, we have to have the same or common denominator, which means the bottom number of the fractions will both be the same. And when we add fractions, we can reduce the fractions or reduce the answer when possible. First question, and first two fractions, 3 over 4 plus 7 over 4. Adding fractions again must have the same common denominators, or the bottom number must be the same. In this case, they're already the same, so our answer would be the same denominator, which would be 4, and the numerators we can add together, 3 plus 7 would be 10. Keep in mind to reduce when possible, 10 over 4. To reduce fractions, you want to divide the numerator and denominator by the same number. In this case, we can divide both the numerator and denominator by 2. 10 divided by 2 would be 5, and 4 divided by 2 would be 2. So 10 over 4 reduces to our answer, and the answer would be 5 over 2, or 5 halves. Second question, 1/2 plus 2/3. Again, adding fractions, first step, we must have the same denominator or common denominators. If they're different denominators, we must multiply one or both fractions to make them the same. A common denominator would be a number that 2 divides into and also 3 divides into. What we can do on this question is make the common denominator 6. Again, 2 will divide into 6 and 3 will divide into 6, so our common denominator would be 6. To change the first fraction to a 6, we have to figure out which number we're multiplying 2 by to get 6. In this case, it would be 2 times 3 would be 6. The top number and numerator multiply by that same number, so 1 times 3 would be 3. So 1/2 is the same as 3 over 6. Changing the second fraction, 2 over 3. Again, 3 times the number would be 6. That number would be 2. 3 times 2 is 6. Multiplying the numerator by that same number, 2 times 2 would be 4. So 2 over 3 is the same as 4 over 6. After changing denominators, we can add the fractions together. The common denominator 6 would stay the same, and adding the numerators 3 plus 4 would be 7. So our final answer, which cannot be reduced, is 7/6. Next question for the section. 5/9 plus 2/12. Again, adding fractions, the first step is to get the common denominator. A common denominator will be a number that 9 divides into and 12 divides into. You could multiply 9 times 12 to get a common denominator. Sometimes, though, there's a smaller denominator rather than multiplying the two. If you think about the numbers 9 and 12, both of those divide into 36. So the lowest common denominator, or common denominator we'll use for this problem, will be 36. 9 times 4 would be 36. So we'll multiply the numerator and denominator by 4. So the numerator 4 times 5 would be 20. 12 times 3 would be 36. So the numerator 2 times 3 would be 6/36. Once we have the same denominator, or common denominator, over 36, we can add the numerators 20 plus 6, which would be 26. Check into reduced fractions, 26 and 36. We can divide each of these by 2. And our final answer would be 26 divided by 2, which is 13, and 36 divided by 2, which is 18. So our final answer would be 13/18. Last question for the section. First fraction we'll have is a mixed number, 3 4/5, plus a second mixed number, 2 7/10. Mixed numbers have a number in front and a fraction, so we have a whole number and a fraction after. In order to add mixed numbers together, we want to change it first into an improper fraction, which means we'll have one fraction without the number in front. If you remember from previous sections, we can change a mixed number into an improper fraction by first multiplying the number times the denominator, and then we'll add the numerator. So 3 4/5 we can change to 3 times 5, which is 15, plus 4 more would be 19, and the denominator would stay the same. So 3 4/5 is the same as 19/5, or 19/5. Second mixed number, again we can take the whole number in front, multiply it by the denominator, and then we'll add the numerator. So 2 times 10 would be 20, plus 7 more would be 27, and again the denominator 10 would stay the same. So instead of 3 4/5 plus 2 7/10, we can change it to 19/5 plus 27/10. Same steps as before we add fractions, we want the common denominator. The denominators of 5 and 10. To get a common denominator, we can actually just multiply the first number by 2, and that will give us a common denominator of 10. Keep in mind we'll multiply the numerator by 2 also. 2 times 19 would be 38, and 2 times 5 would be 10. The second fraction will keep the same, 27/10. And with common denominators, we can just add the numerators, 38 plus 27 would be 65, over the same denominator, 10. Keep in mind we want to reduce fractions when possible. If we have 65 and 10, we can divide each of those by 5. 65 divided by 5 would be 13, and 10 divided by 5 would be 2. So our final answer is 13/2, or 13/2. Title of the last section today is Review, Subtracting, Fractions. In this section, we'll subtract two fractions. Two definitions or two steps for subtracting fractions. First step is must have common denominators. And second definition or second step is reduce fractions. Same steps as adding fractions. When you subtract fractions, we have to have the same or common denominators, and then always reduce fractions when possible. First question and first two fractions. Negative 6 over 11 minus 5 over 11. Subtracting fractions when you have these same denominators. Again, the denominator will stay the same. Combining the numerators, we'll have negative 6 minus 5. Negative 6 minus 5 would be negative 11. Both the numbers will have a minus sign, so we'll add those and keep the negative. Reducing or dividing fractions, negative 11 divided by 11 would be negative 1. So our final answer, negative 1. Second question. 3 over 2 minus 1/3. Again, before we subtract fractions, we have to have the same or common denominators. If we have a 2 and a 3, the common denominator that we could use would be 6, since 2 divides into 6 and 3 divides into 6. Changing the first fraction to a 6, we can multiply the denominator and numerator by 3. 3 times 3 would be 9, and 2 times 3 would be 6. Changing the second fraction, we can multiply the denominator and numerator by 2. 1 times 2 would be 2, and 3 times 2 would be 6. So changing the question to 9 over 6 minus 2 over 6, the denominator again would stay the same, and subtracting 9 minus 2 would be 7. So our final answer will be 7 over 6. Next question for the section. Negative 7 over 8 minus, in parentheses, negative 2 over 5. This question we have a negative fraction minus a negative fraction. If you remember from previous sections, we have a minus minus with no numbers in between, just a single parentheses. Whenever you subtract a negative or a minus minus, we can change both of those to addition signs. So the question is now negative 7 over 8 plus 2 over 5. Still getting common denominators between the two fractions. If we have a 8 and a 5, common denominator would be 40. So the first fraction we can multiply by 5. 5 times 7 would be 35. Since the fraction is negative, this would be a negative 35. And 5 times 8 would be 40. The second fraction we can multiply by 8. 2 times 8 would be 16. And 5 times 8 would be 40. Once we have the same denominators, again the 40 we can bring over. Combining the numerators, negative 35 plus 16. Since we have different signs, a negative 35 and a positive 16, we'll be subtracting 35 minus 16, which will be 19. And 35, the bigger number is negative, so we'll have a negative 19. So our final answer, negative 19 over 40. And last question for the section. We'll have a mixed number, 4 and 2/5 minus another mixed number, 5 and 1/3. Mixed numbers again, we can first change into improper fractions. Again, we'll take the number in front, multiply it by the denominator, and then we'll add the numerator. So 4 times 5 would be 20, plus 2 more would be 22, and the denominator 5 would stay the same. Minus 5 and 1/3 would be 5 times 3 is 15, plus 1 more is 16, so we'll have 16 over 3. Solving from here, we want common denominators between 5 and 3. The common denominator for 5 and 3 would be 15. So the first fraction, we can multiply the numerator and denominator by 3. 3 times 22 would be 66. And the second fraction, we can multiply the numerator and denominator by 5. 16 times 5 would be 80. And 3 times 5 would be 15. Once we have the same denominators, the denominator would be the same, and we'll have 66 minus 80. We can take the bigger number 80 and subtract 66, which would be 14. And the bigger number 80 has a minus or negative sign, so our answer would be negative 14. Our final answer, negative 14 over 15. Title of the first section today is Review, Multiplying, Fractions. In this section, we'll multiply two fractions together. First question and first two fractions, 2/5 times 4 over 3. When multiplying fractions, we'll multiply the numerators together and multiply the denominators together straight across. When multiplying, we do not have to have common denominators. Multiplying the top numbers or numerators, 2 times 4 would be 8. And multiplying the denominators, 5 times 3 would be 15. This fraction cannot be reduced, so our final answer, 8 over 15. Second question, negative 6 over 4 times 5 over 7. Again, multiplying fractions, we can multiply straight across. 6 times 5 would be 30. We do have a negative, so we'll have a negative 30 divided by